Today I present my project on the Dynamic Medium Access Control MAC in the Heterogeneous Cognitive Radio Sensor Network CRSN. I myself, Kishon, being supervised by Dr. Fazirul Hisham bin Hashim. Next, I'll do a short introduction on the Wireless Sensor Network, WSN. Its ISM band is known as the Industrial Scientific Medical Band, which is free. It has a low data rate, low transmission range, but it has a high power consumption due to the frequency sensing, transmitting, receiving, and listening. Next, the Cognitive Radio Network (CRN) operation are for licensed spectrum for primary user, and unlicensed spectrum for the secondary user. As you know, primary user POs, they have to pay for the spectrum, and they give prioritize to the network. And next, WSN is divided into the CRN that produce the CRSN, which consists of the spectrum sensing, spectrum division, and spectrum handoff. Okay, the problem statement of my project is the first one is major issue of CRSN concern is the MAC protocol is due to the no balance between the new WSN applications and common WSN the nodes using CR technology. As you know, the CRN uses IEEE 802.22, whereas WSN uses IEEE 802.15.4. But the ultimate objective of this MAC algorithm for my project is the power consumption without degrading the performance. My objective are firstly to propose a framework for CRSN to ensure the compatibility issue between the WSN and CRSN. And next is to develop a mathematical model for power consumption of the MAC protocol in the proposed framework. This to estimate the level of QoS for the new application, and lastly to evaluate the power efficiency of the MAC protocol, and this to evaluate the optimal working model. Next, and it's the literature review. As you can see, the first one by Akan on the Cognitive Radio Sensor Network. It explains on the general overview of CRSN, where it occupies the network for licensed and unlicensed spectrum band using opportunistic communication. In this paper, it focused more on spectrum efficiency, but it neglected the power consumption part. And next, you can see by Akildis on the Cognitive Radio Ad Hoc Network. It explains on ad hoc CRSN technology. As we know that CRSN consists of WSN and CRN, so it's for a better understanding is needed to help in this project accomplishment. And next, the third one is by Shah and Akan on the performance analysis of CRSN based opportunistic medium access protocol in Cognitive Radio Sensor Network. It states that the importance of the MAC protocol, where it plays a vital role in CRSN. This is because MAC protocol interact closely with physical layer to determine the spectrum holes, and in this paper it proposed a spectrum sensing for CRSN on the CSMA protocol. It results shows better in throughputs and reduce in delay. However, the power consumption is not considered in this paper. So the next one, the fourth one by Zhao and Stau config, crowded on the crowded spectrum in wireless sensor network. And it explains on the WSN technology, where it uses the ISM band free and it's no. And the disadvantage of this technology is it's crowded with many users and has interference with many other technologies such as microwave, Zigbee, and Bluetooth, and etc. So the next one is by Farm on the energy minimization approach for optimal cooperative spectrum sensing in sensor-oriented cognitive radio network. This cooperative spectrum sensing is proposed for CRSN to determine the upper and lower bound for sensing. However, the nodes doesn't minimize the power efficiency, and thus the power consumption is not reduced. So the sixth one is by Hu and Patibalanda on the spectrum sensing in cognitive radio sensor networks. This one is spectrum sensing is proposed for CRSN based partially decaying time incremental STDI, focus on the minimizing of the overhead message. However, the sensing algorithm is not adaptive to minimize the power consumption. And the seventh one is by Jia on the hardware constrained cognitive MAC and efficient spectrum. It uses a single transceiver for efficient spectrum sensing based on the handshake algorithm that have a higher overhead to solve hidden primary users problem, but this algorithm requires high processing, thus high power consumption is needed. And then lastly by Hamodai on OS MAC and efficient MAC protocol for spectrum agile wireless networks, which is opportunistic spectrum is proposed for CRSN where SUs form a group and a node is chosen, and this node is equipped with artificial intelligence where it remembers the characteristic and group members for bandwidth utilization. However, in this paper the power consumption is not considered. Okay, next methodology. As you can see, it's divided into 5 phases, and firstly the literature review, the collect literature review and study analyze on it, and second is the design of the framework. You can see the design framework CRSN for architecture, and third one is the design of MAC protocol and mathematical modeling. The fourth one is the evaluate the performance and the new MAC protocol algorithm, and finally the final research project report and documentation. In the first phase, you can see is an analysis on MAC protocol algorithm for CRSN. Is usually we do a study on CSMA MAC algorithm and a study on spectrum sensing using CSMA CA MAC algorithm. And the second phase is a design theoretical modeling MAC algorithm in CRSN architecture, is to carry out the theoretical calculation for power consumption for CSMA MAC algorithm and CSMA CA MAC algorithm. Is to differentiate between them. And the third phase is the mathematical modeling of MAC algorithm in CRSN architecture. Is basically mathematical coding related using MATLAB. And the fourth phase is simulation process. This proposed model is being simulated using a MATLAB. And lastly, the fifth phase, publication, report writing and documentation. Okay. As you can see here, the adaptive CRSN architecture. This is the architecture I be using for my project. As you can see, this is the data center, and it is connected to a SIG node, and the SIG node is connected to the master nodes and cluster heads, and the master head is also connected to the cluster head nodes, and the cluster head node are connected into the idle sensors. Okay, this is basically the working flow. I can see the SIG node, how the SIG node interact with the idle sensor. It requires a handshake using the CTS and RTS request to send and clear to send method. And this is my mathematical model where you can see each of it has a time taken for contention, time taken TC, where you can see here over here the formula, and the backoff time TB, and for license channeling and sensing time, and the packet submission time. And next, from the above time taken, we can have the power of each node by POW. You can see the power for one node is composed by the contention time, backoff time, sensing time, the packet and idle time, and from that we can have a total power of how many nodes is present by n, can submission by total power of it. And this is the expected result. As you can see, CSMA CA will have a better power consumption compared to CSMA. Okay. And for this project risk is in this project, I think so the main risk is the insufficient resources on the power consumption on CRSN part, and the insufficient time to complete the model project. Next is the project definition strategies. The definitions are aimed to analyze the power consumption of the MAC protocol in CRSN, and the strategy you can see that is to propose the framework for CRSN and to develop a mathematical model for the power consumption part of for MAC protocol and to evaluate the power efficiency of the MAC protocol. And this is my Gantt chart for the first and second semester. You can see over here. Okay, the conclusion is the SMA-CA MAC algorithm in the CRSN can minimize the power consumption and reduce the cost to the end user. And lastly, the MAC algorithm plays a vital role in the CRSN for the power consumption, and therefore I believe this proposal is timely. Thank you.